This clip is about descriptive statistics and, in detail, how to calculate the standard error of the mean. Produced by the Enphe, it's a part of a series of research knowledge clips based on the 5 steps of a research cycle. In this knowledge clip, the focus will be on step 3 and 4, research and conclusions. The goal of the lecture is that you know how to calculate the standard error of the mean. In another knowledge clip, the calculation of the standard deviation is explained. This is the formula. The standard deviation gives information about the deviation in the research sample. So the participants who are measured are described. But in research, we are also interested in the people we did not really measure. Then the question raises, will we find the same mean when we will measure comparable but other people? How accurate is the mean we measure in our experiment? And when we compare it to another group, which will show another mean result, can we be sure that there is a difference? Is the accuracy of the averages good enough? Or is the difference found in our experiment not really true? To express the accuracy of the mean, the standard error of the mean can be calculated. This is the formula. Standard error of the mean is the standard deviation divided by the square root of n, the number of participants. When calculated, the standard error of the mean tells you this. One standard error of the mean added to the mean and one subtracted from the mean results in an interval. This interval tells something about the accuracy of the mean. It tells you that there is a chance of 68% that the real mean found in the whole population will be found in this interval. Additionally, when 2 standard errors of the mean are added and 2 subtracted, a larger interval is found. This interval represents there is a 95% chance that the real average will be found in this interval. In literature, this is called the 95% confidence interval, abbreviated with 95% CI. The interval of the accuracy of the mean, calculated using the standard error of the mean, is usually smaller than the interval of the 95% deviation to describe the sample, in which the standard deviation is used. This makes sense, because the standard error of the mean must be smaller than the standard deviation. It is the standard deviation divided by the square root of the number of participants. The standard error of the mean is quite often used in scientific literature. Now you know what it is and what it tells you.